Hello. I'm Alex. So we'll start the stream today. It will be a shorter one, close to 1 hour. So intending to solve some Rust problems. At the current moment, we have like 88 out of 763, if I recall correctly. So we'll continue our grind. If you recall, from previous episodes, what I did, it's sorting by difficulty, and then sorting again in decreasing order the acceptance. So higher the acceptance, easier the problems. So we're going in a grading mode. So yeah, let's start, guys. So last one which we solved was this one, decode the message. Let's continue with this one. A root equals sum of children. Yeah, there are some updates on the stream. So first update, I try to include music. So yeah, by the way, I'll need to check music quality if everything is good. So let me check on the stream. Yeah, there may be the idea of increasing a little bit the volume. I think that will not be a big issue. So let's try to increase. Yeah, so it should be good. Fine. Okay, so we've got a problem this time. Looks like it's a traversal of a tree. So we played with trees in Rust in our journey to this state. So let's see. I'll sip a mouthful of tea to ease a little bit my throat. Okay, so what's required from us? You're given the root of a binary tree that consists of exactly 3 nodes. The root, it's the left child and it's the right child. Okay, so I don't think we'll even need something else. Return true if the value of the root is equal to the sum of the value of its 2 children, or false. Okay. So first thing, I guess we'll need to unwrap our root. It could be that it's not present. So yeah, I'm using the left screen, so let me zoom it a little bit. Then it'll be easier for me to see the chat. Okay, so yeah, let's unwrap. So if we have something in the root, so that will be the syntax in Rust. Some root will be root. That will be the syntax to get the value from the root. Yeah, this will not work. If that's the case, we will do the left and the right sum. If not, we can return safely false. But I think there is a better structure for this. So we, instead of using an if else, we may use a match. So we can try to match root. So we have some like a node. We'll have some logic. If it's none, then we can safely return false. So this is, it's a little bit more concise. and it will be easier to work with. Now to get the value from a ref cell, so for the node, we can do like a node borrow. So that will be the syntax is to get the value inside the ref cell. So for that we use borrow. And now what we'll need to return, it's like the following syntaxes. Probably for left, let's get the current node, or let's call it current node, and then let's get the left side. Left node will be car node dot left. Yeah, and here we'll need to unwrap as well. But I think a better way to do it, because we may have different scenarios, some of them being that we don't have value. So we may do something like this. We'll need to unwrap as well, so we can do like if let's left node, maybe we can call this root node. Root node will be node dot borrow. So if some left node will be root node dot left. So we check if there is a value on the left side. If let's and we can create a sum here. Let's let mutable sum will be 0 at first, and we can do the following. So sum plus equal left node dot borrow and the dot val. So that will be the syntax is to get the value from the left node. We'll do something similar for the right node. Yes, similar here, either with match or with an if. Let's right node. It'll be like root node dot right, and then sum plus equal right node borrow and val. So we get our sum. Root node val will be root node at val. I think that's the structure. We solved many problems, and they use this one to showcase the value. And what we'll need to return back will be like if root node val, it's equal sum. So this will be what we'll need to return. I think that should be it, whole entire code. Let's see if this compiles. Looks like it doesn't. Why? Yeah, here we'll need to use a reference, otherwise it's moved. So let's try to use a reference in this case. Cool. So it did build. Let's try to submit and see if everything works well then. Awesome. Another problem is solved. Let's move on. Number of arithmetic triplets. Let's check this one. You're given a zero index strictly increasing integer array, nums, and a positive integer diff. A triplet ijk is an arithmetic triplet if the following conditions are met. Nums of j minus nums of I equal diff, and nums of k minus nums of j equal diff. Return the number of unique arithmetic triplets. So in this case, I think what's important for us and what we'll need to try to do, we'll need to create triplets. And there is a function in Rust. It's called windows. So we can try to create windows of 3 elements. Something on those lines, but I'm not sure. Yeah. So yeah, let's try to code it. How windows work in Rust? Yeah, I may be mistaken here, but this is how I remember. So we have like 0, 1, 4, 6, 7, 10. So if we try to create a window, Windows size 3, so this means grouping 3 by 3 elements, we'll have a new iterator, which will be a vector of 3 elements. First one being 0, 1, 4, second being 1, 4, 6. Then we're moving on, being 1, I guess 4, 6, 7, 4, 6, 7, and then we'll have 6, 7, 10. 6, 7, 10. Uh-huh. Though I'm not sure if they are supposed to be in order necessarily, because we may do a combination of those. Like we can pick 0, 4, and yeah, 1 to 4 is an arithmetic triplet because both 7 minus 4 equal 3 and 4 minus 1. So 7, 4, 1. So this will be a triplet. And 2, 4, 5 is an arithmetic triplet because both 10. Okay, so that's an interesting one. Yeah, let's check hints. So this feels like a dynamic programming topic. Two pointers, array, hash table, 2 pointers, enumeration. Interesting. For now, I'm a little bit blanked out on how, because with Windows it will not work. Because we cannot necessarily get them in this order. We may have like as explained here, we may get first element, which will be 1. I mean position 1. Then position 2, which will be 4, and then position 7, not 7 but 4, which will be 7. So that will be a triplet and a valid one. And as you can see from this example, it's not exactly a neighbor and not exactly in order. So in this case, we'll need to think of something else. Another way on how we can go guess yeah, let me think. What will be the approaches here? So yeah, let's use, we can use 3 loops, each iterating through the array to go through every possible triplet. Be sure to not count duplicates. I mean, yeah, for sure, yeah. That will be like a naive scenario where we go with 3, 4 loops, which in our case then it will create a complexity of the algorithm of n cube. But that's not what we want to do. So we want a better approach. I guess for start, because if we want to go with the dynamic approach, then we'll need to play a little bit on our whiteboard. Are the constraints small enough for brute force? Yeah. Yeah, that's interesting. So let's see constraints. Yeah, the constraints are nums is strictly increasing. Okay, so it's strictly increasing. That's good. Okay, so let me think. Should we go with like simple naive approach for this case, or should we try to? Yeah, let's do the following. As it's an easy problem and we have like easy constraints here, maybe it doesn't make sense to overthink it, to go with a dynamic approach. But let's go on our whiteboard for a little bit and try to think of some scenarios. So yeah, I'll need to know the values. So yes, simplest way. Yeah, I'll need the flame shot. Not the constraint I need this first example. Let's try to brainstorm a little bit on the whiteboard, and then we'll see. If it will be hyper complicated, then we'll just do the free for loops. If not, we'll move on. Because with dynamic programming, I'm not super good at it. I have some basic grasp, so this might take a while for me to solve. But let's assume we have our vector or array like 1, 4, 6, 7, 10. So this is our triplet, and the input it's a difference of 3 in our case. So let's assume we will start recursively. So we'll start with this element first. Then we have the option of picking this element. If we get the option of picking this element, then we'll start a branch in this case. Or we can just move on and to not pick it. But let's start to think of the first branch in our thinking tree. Tree, yeah, in our thinking tree. So in our case, if we picked first, then we may have the other option to pick another one, like in our case, to pick 1. If we picked 1, then we have let's say a suit or a starting triplet, and we'll have a difference. So in our case, we cannot pick 1 because the difference it's not free between these two. So 1, it's not possible if we picked 0. So we can move on. So can we pick 4? Can we try to pick 4? No, it's not possible. Is there anything to pick other than this one? No. Is there anything to pick? No, I don't think it is there is any. So then 0, it's not possible to pick, so we will get out. We'll not have a valid triplet. So I guess we'll move on to 1. We have the option, do we pick 1 or not? So if we picked 1 and started our tree or our combinatoric tree, The next element will try to add 4. Now, is it possible to add 4? Yeah, it's possible. So we have one element, and then we'll need to find another one, which the difference between 4 and this one will be 7. So we've got a triplet. This means we can increment our triplet count to +1. So we start triplet count at 0 and we increment it to 1. Okay, so 1, it's a start of a triplet, and we found the first triplet. We can move on, we can start at 4. But if it started at 4, I guess we didn't finish yet with 1, though. That's the tricky part. Because once we've got, where did we? Can we choose another starter for 1? No, because we have our difference. So I guess this ends it. The next one, so let's start with 4. So we need to find a 7, because 4 plus 3 will be 7, and then a 10. So if we find this stuff, we have another triplet, and it will be like plus another 1. And we'll continue for 6, and then for 7, and then for 10. But 10, I guess we can stop at 7, because there are no more elements to form a valid triplet. There are no more elements to form a valid triplet in this case. Okay, so we kind of have an intuitive approach on how to solve it. But now we'll need to code this stuff. Yeah, so we have our vector. And what we can try to do, it's something, it's not necessarily a dynamic programming approach, though we can try the following. So we know the difference. This means we know this, the possible triplet, if it exists or not. So it will be like 3 and 6. So given every time a number, like 0, let's assume, a possible triplet in this case will be 3 and 6. So what we need to do is we'll try to find in our vector if these items exist. If they exist, then we may increment it +1. So there are 2 options on how we can do it pretty fast. It's to create a dictionary or a hash table in this case. Or a map with all, or not even this. What we'll need to do, it's a set. Because what we'll need to create a set and transform all of our items into a set, because we need to find the complements. It's 0, 1, 4, 6, 7, and 10. So we've got our set, and then we have our starting point. So we go item by item. So we go with 0. Do we have a 3 and a 6? So we go 3. We don't have. Then 0, it's not a valid starting triplet. We go with 1. We need to search for 4 and 7, because we do 1 plus diff, and here plus diff. So in this case, we have our triplet. We increment it +1. We go next with 4. It should be 4 and 10. But here it's a trick though. Is considered like 4, 7, 10 a triplet? Let me check. 2, 4, 7, 10. Yeah, actually it is a triplet. So yeah, everything good. So yeah, I've got the algorithm. So yeah, as a rule of thumb, guys, if you have trouble solving a problem, a whiteboard will be extremely helpful. So try to brainstorm a little bit on the ideas on how to solve it, and then out of this you may get into some data structures, cool data structures, find the needed stuff. So yeah, let's check now what will be the complexity of our algorithm. So assuming we'll use a set here, what we'll do, it's transform our n cube algorithm, like doing these pre-for loops, like this brute force, transforming it to O of n, or a linear algorithm, which is a huge improvement. So we trade space using this extra data structure called set to gain like time. So yeah, this is what usually programming it's about, getting space over we're trading off resources. So you may trade off space to get time, or vice versa. So you can increase the time, but to gain space. Yeah, let's code this. Was an interesting problem though. So yeah, Windows will not work. Yeah, let's add our space or set. Yeah, let's call it compliments. Maybe not necessarily the best approach. So we can do iterator, and then let's collect into a hash set. So we'll collect a hash set. Yeah, we'll need to include it. std collections hash set. So we included our hash set. Else I guess we've got our complements, and now item. So yeah, let's create a let mutable triplets. We'll start at 0, and then for each item in nums, now we can consume it. Then we may have some trouble with references here, but let's try. I guess a thing here to do, it's we can do it like this, and then I will not have a lot of troubles. But yeah, in the end, what we'll need to do, it's return the triplets count. It's not, they didn't ask for us what the triplets are, but it's not a big deal for us to find it. So we'll do the following, let write, yeah, let's call it second, will be like item plus diff. Let third equal item plus, or it will be like second plus diff. Or in our case, we can do like item plus 2 multiplied by diff. Because that's the case. And what we'll need to do now, if complements, I think it has second, and complements has third, we can increment our triplets. So that's it. That's the whole algorithm. had vibes of dynamic programming, but it's not a dynamic programming approach because pretty much we don't need to generate everything. So instead of having like 3 for loops, we'll have only 1. Yeah, now we'll need to solve some. Yeah, probably they will ask me to provide the generic argument, and it'll be like I32 here, but it will not allow me to do hash set from I32. Yeah, because that's a reference. We use a reference, an iterator over references. So hash set doesn't, so it contains probably. Contains, I think it's contains. Complements contains second. Yeah, so here it's expected to have in both cases, we expect it to be references. Awesome. So it did work. And we've got fastest solution out there. Yeah, other guys use the free for loops, but we got in 1 millisecond. So as you can see, sometimes, yeah, for sure will not be yeah, this is the same approach, but using not for loops, it's while loops, so similar. So we use a little bit more memory, but that's pretty cool. Anyway, so we've got a decent algorithm, logical, with a little bit of help from the whiteboard. Cool. Yeah, let's move on. I think we solved this. Bank account summary. Yeah, MySQL. We don't do MySQL, so I assume reshape data melt. I assume this one is as well MySQL or something. Pandas. Okay, so pandas. Will be cool to learn about pandas. I think I have it in my goals to learn pandas because it's very, very helpful to do data analysis. I am into investing, stock picking, and I need to process tons of data. So probably pandas will be a very helpful item to manipulate some data. Get the size of a data frame. I feel like it will be the same. Pandas, find center of a star graph. Yeah, that's cool. Find center of a star graph. So we received a vec of vecs, arrays of arrays. Hello, hello. Hi, Mohammed. How are you? Yeah. Welcome aboard. So solving a couple of problems. Today plan to do a shorter stream, but we'll see. Maybe I'll get into a rush and yeah, I don't think I noticed your message right away. So if you're still in the chat, so yeah, welcome aboard. Yeah, Let's see, what's the problem? So we need to find the center of a star graph. Yeah, it started in an interesting way. So yeah, grinding some problems. But I solve easy problems for now, and they go pretty fast. I think I did already a couple. So this is the third or fourth one. I'm not sure. Uh, so yeah, LeetCode, it's a good opportunity to learn a new language as well as keeping in shape on solving algorithms. As a backend engineer at work, I often do like simple data manipulations, mostly getting some data from a database or a service, inserting it back. We're doing some transformation, inserting it back. So we rarely do things a little bit more complex. And if this skills is not trained, um, you get in a very poor shape and lose grip of it. So LeetCode for me, it's a very good opportunity to train and also learn about Rust because at work I do TypeScript in Node.js. Oh yeah, I am. So I am a backend engineer. So work for an American company. Um, Fortunately, in a very like a sensible, not sensible, but through NDA, I'm not allowed to tell the company name or stuff, but I'm working in the clinical trials industry. So working with big pharma companies. So we do clinical studies there. So, but yeah, I think I can tell the subsidiary, the company which I'm employed to exactly, or who pays me. So it's called AW Core. I think I can try to type it in chat. If you search for work, they provide remote work. AW Core. I think that's the name. Great. Yeah, so you can check their website. I think it's awcore.com. So you can check for any new uh, vacancies, if there are any, what they're searching now. But from what I recall, now they search more for Java engineers, not TypeScript. So yeah, that's the trouble. Yeah. Okay. So here, I think that's an easy problem because I assume we'll have only one center. There is an undirected star graph consisting of n nodes labeled from 1 to n. A star graph is a graph where there is one center node. Yeah, exactly. This is what I was expecting. Center node and exactly n minus 1 edges that connects the center node with every other node. You are given a 2D integer array edges where each edge I will be equal ui and vi. Indicates that there is an edge between the nodes ui and vi. Return the center of the given star graph. So we are given the star graph, and then what is expected from us is to find the center. And how we should do that? My idea here, we'll need to transform a little bit the data structure here, or yeah, still we'll need to, because pretty much what's important for us is to count how many times or what's the max amount of Yeah, I would phrase it like this. What we'll need to find is to count for each number how many times it's present in every other node here. So, for example, if we assume or a pair of nodes, and in the end we'll get the most amount of counts will give us the result. So I think in hints here they will suggest to do this is connects all other nodes. Yeah, any two edges must have a common node, which is the center. Okay, so every two edges. So what they tell is like given exactly two nodes, we can identify what's the node. That's the idea. Yeah, probably that will be the idea. So yeah. Okay, how can we write this code? One way to do this will be something like, by the way, Mohammed, if you're still in the chat, do you write Rust? If you write Rust, how do you find this language? Okay, so let's type our answers. Oh, Java and C. Cool, cool. Yeah, I used to write C a long time ago when I started coding. So we started with C. Java, I didn't get my hands on. I was more into scripting languages like PHP, Python, JavaScript. But lately, yeah, actually, it's a couple of years. In 2018, I started playing with Rust, and I felt like it's a very solid replacement of C. So I started getting deeper into it, and it's pretty powerful. It doesn't have a garbage collector and it has a pretty powerful compiler. Hints you a lot of issues, troubles. It's complex. I would not tell that you'll get very fast and you'll learn, have a pleasant learning curve here in Rust, but it's enjoyable. So I feel I'm very productive and I like it. Yeah, let's code it. So my idea, I guess, if we know that our star, or how can we call it, star graph will have only a center and all the other nodes will be connected. Yeah, exactly, exactly. This is what I want to. This is what I want to do. I guess I was thinking that you may have not a star in this form, but you have like um, yeah, maybe I should draw it. But so let's assume we have like a star, middle two. Here we have like one. Here we have like three, but we have like a four as well. and then here we have a 5. So in this case, it's a little bit more complex because you'll need to get some sort of depth first search or breadth first search to get to the root, to see if this stuff is connected, or also, but it's not the case. In our case, it's a simple graph like 3, and here we can have 4. So in this case, it doesn't matter. So we can pick only the first 2. Yeah, we have many leaves. Yeah, exactly. But in this case, yeah. So let's get the first 2. Let first will be edges of 0, and let second will be edges of 1. Even here, I guess we can destructure it, but not necessarily easy to do. There is an into function in Rust, but it's not for this Rust version because I've tried it. Because there is a way. So for example, we can do it like that. So we can call into and then unwrap. And here we can set like u1, u2, where 1, 2, and 1, 2, something like this, 1, 2. So we'll get exactly the values. Yeah, exactly. This is my initial idea. So I was planning to get a hash map and then store how many times I've seen a specific node inside these edges. So for example, for this 1, it will be counted 1 time, 2, 1. Here we have 2 the second time, 3 1 time, 4 1 time, and 2 will be the third time. So I will get the max out of these numbers, and this will be my center. Oh yeah, they do. I solved a problem a couple of moments ago with with a hash map. Actually, with the hash set, but yeah, it's in the same collection. So hash maps and hash sets sit in. You can use like use std collections, and you can use like hash map, hash set, binary, heaps. What else do we have? Like vecdeck or queues. Stacks, you'll use just a simple vector or an array. Yeah, so we've got this first and second. So now what we can check. Yeah, we'll need to do like a couple of combination because we may get like a first value, second value, or not really. Yeah, maybe I can do it a little bit different. Oh, how can I do that easier? I just don't want to write if first of 0 is equal second of 0, then it's first of 0, stuff like this. How can I write it in a more convenient, pleasant way? So we know that we'll have a duplicate. To use a hash map for this? Yeah, I guess the funniest approach can be something like this. So we've got first and second. Then we can do like but yeah, probably we don't even need to do. Let's do it like this. So edges, we do iterator, we take only 2. Then we do a flat map. No, actually we will not do a flat map, we'll do a flatten. because we want it flattened. Yeah. So here, let item in this. And then we'll do, yeah, actually we can use a hash set for this case. Let's use for the sake of the example. Set will be hash set new. So if set contains item, we've got our we can return item. Else set insert item. And kind of we know that this will finish. It should finish. I hope it will finish. Because in Rust, yeah, this will work. But the problem is this will not compile in Rust. Just a for loop with the number already exists, and just upgrade the counter in the hash map, also create a new key and its value. Yeah. That's but I don't need a key and a value, because I can check if because I know it will be only one time. So if it contains already the item in the hash set, then we don't need to use anything. Yeah, other languages this will compile and even work. I'm not sure about Java, but in Rust it will not allow me to have parts of code which it doesn't finish. So I'll need to write something here in order for this to compile. I need to return something. Yeah, it will tell like what's the trouble? Hash set. Yeah, I'll need to include the hash set. So yeah, use stt collections hash set. And I guess to fix that, I'll need to panic. Should not get here for this to compile. Otherwise, and even that will not, I'm not sure it will compile correctly. Yeah, we'll need to dereference this because that will be a reference. Yeah, this compiled and worked. So cool. Let's submit this. Yeah, and looks like it's not. Not really. In JavaScript, you cannot. So in JavaScript, you may not return. Yeah, because you don't have a type there. So that's funny. So in languages which you don't have, which are not strongly typed, you may not return a type if it's required. Yeah, let's check other solutions. Yeah, hash set, looking contains, return, insert, to do. Yeah, that's a pretty funny. Exactly the same approach. I mean, he wrote it the same using a hash set. So he gets the first item, the second. But actually, I'm not sure why does it do for all vertices. Because he doesn't need to. Only two of them, it's enough. Yeah, I'm coming from JavaScript. You need to know that. So in JavaScript, you can write code like this. Yeah, yeah. Have a good night. Yeah, thank you for joining. Wish you a good night as well. Was a pleasant discussion. Okay, so let's move on. We'll try to solve another one. So we are up an hour. Yeah, let's check this one. What's filter elements from an array about? That's a JavaScript one. Filter fan. Cool. So yeah, that one was a pretty fast one, but we solved. Let's move on. I just don't want it to be empty, so I like the green check marks. Count k differences. Count number of pairs with absolute difference k. Yeah, I feel like that's exactly the same problem which we solved. But this one, it's instead of having like a triplet, we need to do a pair. So same approach, I think. I will not find anything new here. So we have the difference. Return the number of pairs ij. So I guess let's write the code. So first thing we'll create our complements. Let's collect this as a hash set of I32. Yeah, that's exactly the same problem. Let's use it. Not solution. Oh my god, collections hash set. So we've got our complements. Next stage, it's find duplets in this case. Let mutable duplets. Yes, duplets start at 0. For each duplet, for item in num iterator, let's check the item. Let complement will be item plus div, or k in our case. If complements contains complement, and this should be a reference, we increment our duplet. And we return our duplets. So yeah, exactly the same problem. This one, it's using yeah, let me check one thing here. Can we check every possible pair? Can we use a nested for loop to solve this problem? Yeah. So there it was 3 for loops. Here is 2 for loops, but in either of the cases we don't need like neither 2 or it's still 1. So yeah, let's see if this compiles. It's a little bit different than in this case though, because it's absolute value. Oh yeah, that's a little bit more complex. We have an absolute value here, so I guess we can find two complements here. one or the other, because we may have a complement with plus. Wait, yeah, let me think. How many possibilities we may have? So assuming we have like, assuming we need to do the following. So we have like 3, 1, 2, and 6, and we have a difference k in our case equal to 1. So we get 3. The difference, absolute difference, or let's we can tell like x minus 3 should be equal 1. So here we can have two possibilities. Either will be 4 or could be 2 for x. So x in our case, it will be like 4 and 2. So in our case, then we need to search in our set for, if we call like 3 will be a j, then we need to search in our set for a j minus 1 complement, or j minus k in our case, because 1 will be k, or j plus k complement. So these two complements, one or the other. So if we find one or the other, then we found our complement. So yeah, then we have item plus k. Yeah, item in our case will be the j part. So yeah, compl 1, and let's do compl 2, which will be item, what did I write here? Or item minus k. So if complement contains, this will be compl 1, or complements contains compl 2, one of these two, then we increase our, then this should work. Okay, so we've got output 5. Let me think. I think I have a problem. Let me see here. J minus k, or item minus k. Yeah, I'm a bit confused. Okay, so it's not j here. Yeah, let's play a little bit with the formula, because I think I messed up the formula. So let's assume this will be item, as in our vector. So we have a complement will be x minus item modulo will equal k. So we know k, we know item. Then we need to find what x will be. So let's use a couple of examples again. So x minus 3 in modulo will be equal 1. Then what should be x? X in this case will be either 4 or 2. Okay, so what's the relation between 4 and 2 and 3 in this case? Will be item plus 1 or item minus 1. And what did I write here? Item plus k or item minus k. Yeah, let's check the third case and try to understand what's the trouble. So we've got like 3, 2, 1, 5, 4, and K2. Yeah. So we've got the following like 3, 2, 1, 5, 4, and the difference will be 2. So assuming we've got 3. So 3 plus 2 will be 5. It's 1 complement. And 3 minus 2 will be 1. So we've got 2 complements in this case. Yeah, what's the trouble? Output is 5. Okay, so we've got complements for this case for 3. So it's 1 and 5. So actually, yeah, that's a little bit more complex than I thought. Or is it? So, because we know that for 3, we search for these complements. But if we find 1, good, but we find 2, also good. Okay, so probably I shouldn't do it like this, but I can check separately, because these are distinct elements. If complements contains compl2, duplets plus equal 1. Because we may get both of them, and we should count both of them. Yeah, let's check that. And we have a little bit more than expected. So let's check why. So for first value, we found 2. So let's get the next one. So for 2 plus 2 will be 4. And 2 minus 2 will be 0. So we have plus 1. Here we have plus 1 and plus 1. So we will have at the moment 3 of them. 2 plus 2 is 4. So we have 4 in the system. Yeah, let's move on. Then we have 1. Yeah, I think I understood. We do not need to double count them, because we are double counting them. 3 and 1 and 1 and 3, it's already counted. So we double count them. That's the trouble. And how we can assure that? Maybe once we got the item from the set, what will happen if we remove it? Let me think. So assuming we've got the following algorithm. So we've got our set, we've got our values in our set, 3, 2, 1, 5, and 4. We've got first item from our vector 3. Then we've got the complements. In our case, it will be 1 and 5. So we remove this 2 from this set, and we've got here, it will be like plus 2 complements. We've go next will be 2. We've got the complements to be 0 and 4. We have only 4. We remove it, and we'll have like plus 1. We move next to 1. We search for 3. We still have 3 in the set though, but maybe we should check if 1 it's in the set, because if we use it in other in other yeah, so probably the algorithm should be something like this. We get the item only if it exists in the set. If it exists in the set, then we will try to add our tuples. If not, then there is no point into doing. Yeah, so yeah, let's try this. So we've got our complements, but first thing which we'll need to do, it's add another thing here. If this is right, yeah, this became a little bit more complex already. And then we do duplets plus 1 and complements, remove comple 1. And here we'll do complements, remove comple 2. Yeah, let's try this. Now we'll, I hope we'll avoid our duplicates. Yeah, let's make it mutable. Yeah, we cannot run it as fast. Yeah, looks like this approach didn't work either. Okay. Then let's use another set. I think the easiest way will be to use another set. We can call it used, and then we'll do a hash set new. So if complements, not complements, but if used contains item, then we'll do used add or insert complement 1, and here used insert complement 2. Yeah, we cannot insert a reference. Okay, so what's the problem? Yeah, this modular stuff, it's a little bit annoying. Yeah, let's keep it simple for now. Let's go with the first approach. with the first approach, and let's try to optimize it to work. Yeah, simple problem. If you are stubborn and do not want to use like 2 for loops and want to make it a little bit faster, then you'll need to trade with a couple of minutes trying to think of how to optimize it. How can we know that we used it already? I guess a thing which we can do. Yeah, actually, a thing which we can do is we can make this a little bit more complex. Or we cannot, we should not call it like used, but more like yeah, let's call it pairs. And this will be a hash set of a tuple, like two I32s. So we will store the pairs here, because I assume we'll not have as many. So yeah, it's a pretty small number. And we will not want to count already stored pairs. So it will be something like this. Yeah, we'll still have the two things, so complement one. But we'll do a check, like if pairs contains, and here we'll set like item and compl one. If we have this pair, or pairs contains, so we need to go with the both ways. Compl one and item. Then we'll do duplets plus one, and we'll need to insert our pair, but in two orders. So we'll have like pairs insert, and we'll do this first and the reversed order. So we'll make sure to not double count them. Pairs insert item complement one and item. And we'll need to do the same for the second. So complement two. Yeah, this will not compile yet. We'll do a complement two. We'll do here complement two. So let's try to run it. Yeah, item in our case will be, we'll need to dereference it, and I guess here we'll need to insert it in a different dereferenced way. Yeah, welcome to Rust, guys. Yeah, I think I missed a couple. Yeah, these ones. So it doesn't work. Oh my god. So first K1 output 0. Yeah, I give up. I give up. Let's try to work on this in VS Code and try to debug it a little bit and try to understand where's the trouble. So with triplets, we solved it pretty fast. But here, the trouble is this modulo and double counting it. Yeah, probably it's late and I have like my mind, it's a little bit blank. Okay, so dojo, cargo, new. Yeah, how this stuff is called. Yeah, count number of paths with div k, and we want it to be a lib. Yeah, let me open this one. Oh, we've got here our screen. Yeah, let's try to paste our solution. So we'll need a struct for our solution. Yeah, this is not needed to be mutable anymore. So we have some updates, and here, yeah, we'll need to add our test cases. Let's add our scenarios. Yeah, this I don't need. So example 1. So we'll have vec and k will be 1. Let's move on to this part. So we'll have solution, count k difference, input, and k. So we'll have, yeah, actually we'll have the input tuple, and then we'll have the resulting tuple. So result will be 4. So here I will have nums and k. So we'll do here nums and k, and this will compile and work. So yeah, let's add all the examples and try to figure out what's the problem in our solution. And I think that will be the last problem for today. So yeah, an easy problem, but we have troubles solving it. Cool. As always, cool stuff. So what's the difference? K will be 3, expected to be 0. And next will be this one, K2, and expected to be 3. So yeah, if we run now our test, we have left 0, right 4. So first test is failing. It's not right. Why? Let's debug it a little bit and try to understand. Okay, so triggering debug and trying to see what's the issues. So we've got the following variables. So we've got 2 complements. So complement 1 will be 2. Yeah, that's interesting because we have like 1, 2, and 2, 1. But where did it get 4? Yeah, interesting. Okay, so if complements contains complement 1, I think it does. And unfortunately, we do not know how many times. Because we will count pair contains. Yeah, here we'll need to do it doesn't contain, because that will be bad. So yeah, first bug which we identified is that it doesn't contain. At least we found one. So yeah, one it's kind of expected, but it's not correct. So yeah, maybe we should use a hash map. So just count. Yeah, let's try to use a hash map. But even with the hash map, it's tricky. Where did they identify 4? I don't get it. So 1. Okay. 1 and 2. 1 and 2. 2 and 1. And 2 and 1. So it's still double counted, as I understand. Yeah, that's a weird solution. I don't get it. So they count 1, 2. No, they use this one. Okay, so 1, 2, and 1, 2. And for the second, we use 2, 1, and this 2, 1. So yeah, we've complicated it too much. But I think initially I was on the right path. But maybe I shouldn't use it like this though. Yeah, let's clean it up, because I think I am it's way too complex here. Yeah, first complements. So compl 1. Still, we'll need to have this too. That's impossible with it. So we'll be like item plus k. Let compl 2 will be item minus k. But here, instead of using this stuff, we will do it a little bit different. So we'll not have a hash set, but we will try to have a hash map and count. Yeah, let me do it like this for this example. So let's assume, yeah, let's change a little bit the color. So let's assume we have like 1, 2, 2, 1. Then we'll have a hash set of 1 counting 2 times and 2 counting 2 times. So in this case, when we do our algorithm, we'll do something like that. Assuming item 1, and diff will be 1. Complements will be either item plus 1, which will be 2, or item minus 1, which will be 0. So we'll have 2 possibilities. The next stage, we will check how many items, how many complements of 2 do we have in the system. And we've got, like, we have 2 here. Then we'll do duplicates plus equal this number plus 2, because we have 2 of them, 2 of 2's. But we did operations already with ones, so we'll need to decrease 1, 1. Yeah, but we did operation with 2 as well. Yeah, I'm not sure how they counted. That's a trick, as it's counterintuitive. In one way, they yeah, confusing. Anyway, okay. So let's try to move on. So we do our duplicating part, and we remove one from here. And the solution will be something like in our map, we'll have only 1, 1 and 2, 2's. Or actually 0, 2's, because we did operation with them. Yeah, but how in the world then they do this? If this is used and this, how? No, that's weird. So this doesn't work. Because I mean, what they want to do is, like, we have all possible combination, like 1, 2. Then we have like 1, 2 again, and they have like 1, 1. Then we have like 2, 1, 2, 2, 2, 1. And for the second, we have like 2, 1, 2, 2, 2, 1. And for the last one, we have like 1, 2. Not correct. It's like 1, 1, 1, 2, 1, 2. So we should have like 3 from all possibilities. So this will be like first one. This will be like first one. This will be like first 2. This will be like second 2. And this will be like third, or a second 1. So out of this combos, how many of them have difference k? So this will be like 2. I mean this one and this one. Here, how many we have? 1. It will be like this and this. To be like another 2. Okay, so yeah, they do not double count. Because if they did, then this and this and this 2 would have been like 8. So indeed, they do not double count. But they do not double count specific order. So I was somewhat right. I was somewhat right. Yeah, let's get back here. So we have this. Let's add back the pass. Let mutable pass will be a hash set of I32, I32, and it'll be like hash set new. We've got our complements, and then we do, yeah, and we need this. If complement contains complement 1, let's assume we go with complement 1, and we don't have a pair. If pairs contains, here we'll go specifically item, item and complement 1. We'll go in this direction. What's the trouble? Yeah, this needs to be dereferenced. Yeah, and this needs to be referenced. Yeah, weird stuff. Then we'll do duplicate let mutable duplets plus equal, not plus equal, but just equal 0. And here we'll have like duplets plus equal 1. And we'll need to insert a pair. Pairs insert. We'll need to insert this. So item compl 1. So we did insert the pair. So we'll need to do a similar check for the second. So exactly this, but for complement 2. And let's run it. 2 and 4. So looks like still we've got troubles. Yeah, let's check why. Yeah, let's check why, because here, yeah, because of this. Indeed, there are 2 of them, but we need to count them both, so we cannot deduplicate them. So we've got 1, 2, and 2, 1, but they will be counted only once, but they need to be counted 2 times. I guess this one, it's literally cannot do anything either than do 2 for loops and check the differences and do the counts. Yeah, I do not see another way on how we can do it. As it's getting very complex. And okay, let mutable duplets equal 0 for I in 0 nums_len, for j in 0 nums_len. Yeah, probably here we can do like this to not double count I and j. If nums of I minus nums of j ABS equal k, then this plus equal 1. So with triplets was easier, but looks like this one you cannot do it in the other way, or maybe you can, but my mind it's not. So yeah, let's do cargo clippy. Let's see if there are any suggestions for us to improve. No, there aren't. Let's do it like this. So yeah, sometimes you just need to do it simple. You don't have any other option. Yeah, I'll think of a way on how we can improve this. I'm pretty sure there should be a solution for that. On how we can optimize it. Wrong answer. So yeah, looks like not correct. Yeah, let's check this test case. Yeah, how a similar problem is not at all similar. That's interesting. Okay. Okay, so what's the trouble here? Yeah, let's try to go like this. I mean, that would be like a 8 equal 4. No, we cannot do it like that. So yeah, we kind of need to go like this, starting at 0 and pre-last. And here starting at 1. And last. And what's the trouble? So first 3 are good, but the fourth one, we've got 8, but should be only 3. How? That's a little bit interesting. 2. So okay, so the difference it's 5. It's not 2, it's 5 the difference. We've got 2 only. So yeah, let's check. 10. Okay, so what stuff gives indifference 5? So 6, 1. Okay. What else? 2, 7, 6, 1. Yeah, I don't see it even. How? What? Yeah, let me double check if that's a correct thing. So difference 1, difference 3, difference 2, and difference 5. So where are the three of them? So 1, 6, and 6, 1. That will be 2 of them. Yeah, maybe I didn't read correctly the problem. No, this is something not right. I mean, that's oh, so it's expected to be 1, though I've put 2. How in the world do you understand which so 1, 6 and 6, 1, it's the same thing. Yeah. So still we'll need to deduplicate it somehow. Yeah, looks like that will be, it's not 3 actually, it's 1, but we put it to be 2. Because the 6, 1 and 1, 6 will be double counted. I guess yeah, let's try a simple trick. Visited, like a simple hash set. But I'll not include the value here, but I'll include the index. So this will be like a hash set of of usize. Yeah, I'll need to include it. Yeah, so we're not visited but seen. Okay, so if seen doesn't contains I or seen doesn't contains j, then we do this, and then we do seen insert I, and we do seen insert j, and then we'll make sure to not use again to double count it. But in this case, I feel like others will fail. Yeah, in this case, first one fails. Because for 2, 2, it's 1 and 2 was seen. Yeah, let me check for the first case, because this one will work in this case. I'm pretty sure it will. Yeah, indeed it works. Let's check the second. Second works as well. This one works as well, but first one fails. And let's try to debug it. It's 3 duplets, not 4. Yes, it's not seen, but let's use used, because that will be a better name for it. Okay, so we have like I0, J1. Neither of those are used yet. So we will include in used 0 and 1. So we used both of them. We move on. But wait a second. Why should I no, I don't think I should insert the J as well. I should check only for I. I think I should check only for I. I should check only for I. Where Let's check this if this works. It's 2, should be 1. Okay, how about J? Yeah, should be I and J. I or J. Yeah, it's a little bit too late and I still cannot figure out how to solve this easy problem, which actually everyone else looks like it did already solve it. So, yeah, looks like we have 2 options. First option, to check the solutions. So, Rust. Okay, so they do it like, oh, so yeah, my freaking god, I just had this, oh my god. Yeah, so as you can see here, probably this guy played as well a lot of time. So yeah, but here it's not like this. So he moves with 1 plus. Okay. Anyway, so that will be it. I didn't use the right iterator. So that's funny. Look here. So this guy uh, tried with the same approach as I did first. And then looks like he got bored or didn't found a solution and still wrote this 2 for loops. And left behind the diff frequency because he doesn't need it. Okay, so let's submit and go to sleep because it's too late for me to figure it out. But yeah, if you have troubles with the problem and you struggle to solve it, I do not see any shame into looking at the solutions because there is one goal to what we're doing here is to learn. So yeah, that's all which it is about. Okay, so I think we are good for the ones who joined and were here with me. So thank you guys. Wish everyone a nice evening.